takes the average CPU load over a specific time period. On Linux, load average is displayed for at least 1 minute, 5 minutes, and 15 minutes. This is these numbers. You see, first line load average, 0.12, 1 minute, 0.13, 5 minutes, 0.15, 15 minutes. And that means load average 0.25, 1.20, 1.90 indicates that the load on the system is coming down. 0.25 is the load average in the last 1 minute. 1.20 is the load average in the last 5 minutes. And 1.90 is the load average in the last 15 minutes. And load average is going down. This load average is calculated by combining both the total number of processes in the queue and the total number of the process in uninterruptible task status. Then when we are talking about disk I/O optimization, all Linux distributions ships with 4 different I/O schedulers. They are deadline, NOOP, anticipatory, and CFQ. There are many differences between these scheduling algorithms. The default scheduling algorithm is CFQ. This is default in most Linux distribution. It attempts to distribute all I/O bandwidth evenly among all processes requesting I/O, and it's ideal for most purposes. If you check on your laptop, on your client PC, which algorithm you use, it will be CFQ. Then NOOP. This algorithm attempts to use as little CPU as possible. It acts as a basic first in, first out queue, expecting the hardware controller to handle the performance operation of the request. If you have notebook, server, whatever, with solid state disk drive, use this. Your computer will be much more faster. Try it. Anticipatory, this algorithm attempts to reorder all disk I/O operations to optimize disk 6. It's designed to increase performance on systems that have slow disk. Okay, if you really have slow disk in your computer, in your notebook with 4 RPMs, try this. It will be much more faster than CFQ. If you have disk with 7,200 RPMs, then just use CFQ or deadline. And the fourth, deadline, this scheduling algorithm places I/O requests in a priority queue, so each is guaranteed to be run within a certain time. It's often used in a real-time operating system. In company where I work, we have a lot of work with Oracle databases and Oracle web application servers, and we always use deadline algorithm. How to check which algorithm are you using? Simple. cat sysblock SDH or your disk, queue scheduler. I'm using this one in brackets, CFQ, on this computer. If you want to change it, just put this command line, or if you are using SUSE Linux or OpenSUSE Linux, you can do this in YAST via kernel settings. Changing schedulers on the fly allows you to test and benchmark the algorithms for your specific application. Once the change is issued, any current I/O operations will be executed before the new scheduler goes into effect, so the change will not be instant. You must wait maybe 15 seconds, 1 minute, but this will be quick. Also remember that once one is set and performs to your liking, be sure to set the change to be applied on subsequent reboots. It's often recommended to use NOOP or deadline on any SSD drive. As I said, if you have SSD drive, try NOOP, it's really fast. On LinuxCon conference last year in Edinburgh, I have talked with some guys from Israel. They have all servers with system on SSD drives, and he wrote me mail 1 month after conference, and he said that it's really quicker and faster access to the disk. There is usually no definitive answer to which algorithm to use. You must try it. Benchmarking, each one will be your best option. There are cases where CFQ may not be the best scheduler for your system or applications. As I said, CFQ is default algorithm on your computer, and it's not always the best choice. An example is if you are running a RAID disk array with cache and create controller. If you have cache and create controller in hardware controller, computer will set that CFQ is the best, but this last one deadline is always better choice. I/O optimization. I/O wait is the amount of time CPU is waiting for I/O. If you see consistent high I/O wait on your system, it indicates a problem in the disk subsystem. You should also monitor read seconds and write seconds. This is measured in blocks. Number of blocks read-write per second. They are also referred as by and bow, block in and block out. TPS indicates total transactions per second, which is sum of read transaction per second and write transaction per second. Then always choose the quickest file system. You can choose between ext2, okay, it's very old, it has no journaling. Then we have ext3, it's still default in some older distribution. Then if you choose, if you install maybe /10, the default file system in /10 is still Riser FS. Don't use it. It's not developing anymore. We all know what is with Hans Riser. So choose ext3 in /10. Then if you are using this newer distribution, /11, Red Hat, Ubuntu, use ext4, or you can use BTRFS in /11. But BTRFS is quick, but it's not supported by some third-party program vendors like Oracle. If you will use a database server, the web application server on BTRFS, they will set, so this is not supported. And you can always tune file system options in FSTab. You can always choose options like NOAA time, no DIRA time, and your file system will be act much faster. Then when we are talking about disk I/O optimization, we are talking about RAID, software or hardware RAID. Many of us are still using software RAID because hardware RAID is maybe not implemented in kernel from our RAID vendor. So you can use RAID 0. Okay, this is not mirroring, this is striping. Then RAID 1. Never use RAID 5. It's not recommended. It's very slow. If you want to use something like RAID 5, it's better to use RAID 6. And RAID 10 is the best choice, but you will lose half of your disk capabilities. When we are talking about disk optimization, you must always use benchmark programs like maybe Bonnie++ to measure disk speed of disk. You can use HDPARM, SDPARM. You can always upgrade BIOS of your server and firmware of your disk, and check if your disk is maybe park your head. Okay, the parking the head, it's not thing on server disk, it's much more thing on desktop disk. If you have maybe disk, this Western Digital Green or this series, it will park your it will park heads, and this startup will be much slower. But you can always change firmware of your disk and change this disk parking settings that this disk will not park the heads. Okay, about network tuning. A good understanding of TCP/IP concepts is helpful while analyzing any network issues. For network interfaces, you should monitor total number of packets received and sent through the interfaces, number of dropped packets, and so on. In a company where I work, we recently, I think 1 or maybe 2 months ago, bought Oracle Exadata and Cisco UCS servers. For Oracle Exadata for storing information like data warehouse, and Cisco with 8 blades, Cisco UCS blades for virtualization. We have measured, Cisco has 2 10 gig switches, and we have measured network performance from Oracle Exadata through these 10 gig switches to blades on which are running on UCS. On a 10 gig network, the maximum throughput was 3 gigs. Not good. So why? Linux from itself, I hope that you see this. Linux for itself, it's not made, this network IP stack is not made for 10 gig network. But if you change these variables in a proc file system, you can expect bandwidth will increase from 3 gigs to 6 or 7 gigs. And these variables are ideal for servers that are serving up huge numbers of concurrent sessions. There are some TCP options that should probably be enabled with a large number of clients doing their best to kill the server. It's probably not uncommon for the server to have 20,000 or more open sockets. You can change these settings and your network will be much faster even on 100 meg switches. But if you are using 10 gig switches and 10 gig network cards, it's always the best idea to increase TCP max buffer size, increase Linux auto-tuning TCP buffer limit, increase the length of processor input queue, and the most important, recommended default congestion control to change it to HTCP, and to enable if you have enabled jumbo frames, it's the best to change MTU probing. Okay, if you are using 10 gig switch, it's always the best that you are using jumbo frames. That means that you must use MTU 9000. We have determined this, I think, 2 weeks ago. But if you are using jumbo frames or MTU 9000, your switches and other equipment and other servers must support this. This recommended default congestion control. What is congestion control? TCP congestion avoidance algorithms. We have 6 algorithms. The default algorithm in all Linux and Unix and all computers and the Windows operating system too is Reno, traditional TCP used by almost all operating systems. Then we have cubic TCP, BIC TCP, HTCP, Hamilton TCP, which is the best solution if you have 10 gig or faster NIC. Vegas, TCP Vegas, and Westwood, which is optimized for loose networks. So if you are using 10 gig switches, use Hamilton TCP. How to determine which are you using? Just write down this comment. I'm using Cubic and Reno. This is some mixture in a newest Linux distribution. But if you use 10 gig switch, just change it to HTCP. Oops. Okay, next slide. About memory optimization. If you have 16 gig of RAM installed in your servers, you have 16 gig of physical memory. Virtual memory, it's swap space available on the disk. plus physical memory. The virtual memory contains both user space and kernel space. Using either 32-bit or 64-bit systems makes a big difference in how much memory a process can utilize. On a 32-bit system, a process can only access a maximum of 4 gig of virtual memory. And on 64-bit system, there is no such limitation. When we are all using 32-bit system, it has always been problem with swap space. They have said, okay, we have 2 gigs of RAM, and I have installed one software for commercial software for proxy servers. I don't remember which one. And they said, okay, you need 2 gigs of RAM and 10 gigs of swap space. But yeah, quite Trend Micro, one of Trend Micro proxy servers, but don't know which one. And it's not going. You cannot use more than 4 gigs RAM on 32-bit system. So what you can do, just make 2 4 gigs partition and 2 gig partition of swap space. But this is history. Unused memory will be used as file system cache by the kernel. Linux system will swap when it needs more memory. When it needs more memory than the physical memory he has. When it swaps, it writes the least used memory pages from the physical memory to the swap space on the disk, but this is slow. A lot of swapping can cause performance issues, as the disk is much slower than the physical memory, and it takes time to swap the memory pages from memory to disk. When we are talking about memory optimization, in past years, 2-3 years ago, we have new technique, dense memory. We have NUMA, non-uniform memory access. We all know huge pages, and we can manage virtual memory pages with flashing dirty pages and to change swapping behavior. Okay, NUMAT. Have anyone heard of NUMAT? NUMAT is one daemon. It's user-level daemon to automatically improve out-of-the-box NUMA system performance. It's available in Fedora 17, Red Hat Enterprise Linux 6.3, SUSE Linux Enterprise Server 11, and OpenSUSE, I think, 12. It's not enabled by default. This daemon monitors available system resources on a per-node basis and assigns significant consumer processes to aligned resources for optimum NUMA performance. It rebalances when necessary, and it provides pre-placement advice for the best initial process placement and a resource affinity. If your service is some kind of hypervisor for KVM, Xen, or such open source virtualization, switch on NUMAT. Just switch it on because default, it's not enabled by default. Then huge pages. 2 meg pages versus 4K standard Linux pages. Virtual to physical page map is 512 times smaller. TLB can map more physical pages, resulting in fewer misses. Traditional huge pages are always pinned. Transparent huge pages are available in Red Hat Enterprise Linux 6 and /11, as in OpenSUSE 2. Most databases support huge pages. If you install Oracle database, it will always write that you must enable huge pages. 1 gig page is supported, supported on newer hardware. How to configure huge pages to 16 or here on to 8 gigs, just echoing to proc file system, and you will use huge pages or this command in sysctl. Flashing cache, we can drop unused cache, freeze unused memory, file cache. If the database use cache may notice slow down, how can we free page cache? Just echo 1 to drop caches. how can we free slab cache, just echo 2 to drop caches, and echo 3 to drop caches to free page cache and slab cache in the same time. This will not happen instantly. We must wait few seconds or few minutes, and it doesn't help always. Swappiness. Swappiness controls how aggressively the system reclaims mapped memory. Default swappiness on OpenSUSE and all Linux distributions is about 60. Decreasing 60%. Decreasing this number means more aggressive reclaiming of unmapped page cache memory. Increasing this number means more aggressive swapping of mapped memory. Which is the best? You must try it. You must try and benchmarking. It depends of what kind of server is hardware-specific server, for what purposes you are using your server, and so on. When we are talking about optimizing, we must always remember the 18-20 rule. That means 80% of the performance improvement comes from tuning the application, and the rest 20% come from tuning the infrastructure components. Which are the best system monitoring tools? You know all these tools: VMstat, netstat, PSTop, ATOP, HTOP, MTOP, IOStat, and XOSView. Nothing specific. Then kernel tuning. When we are talking about kernel tuning, it's always a good solution to recompile your kernel, to make your kernel smaller. But if you recompile your kernel, exclude unneeded modules on enterprise distribution like Red Hat Enterprise Linux or SUSE Linux Enterprise Server, then your vendor, Novell SUSE and Red Hat, will not support your recompiled kernel. You can buy from them a real-time kernel, but real-time kernel options on Red Hat and SUSE are not cheap. So if you want to recompile your kernel, I have, just a second, I have one PDF where you can see which are the best options for recompiling. These are kernel configuration options. This is command line options when you are making make config, and which are default options, and which options you must change to use small kernel options. Tune some kernel data sizes, tune some net-related data sizes, to turn on kmalloc accounting, print out all bootmap allocations, and so on. And these options are, it's not so many options, but your kernel will be smaller and will be much faster. You can buy a real-time kernel from your vendor. It will, the license costs are 10 or 20 times higher than ordinary kernel, but you can do the same thing with this, and it will take you, your 15 or 30 minutes of your time. I will put this slide also on a conference link that you can grab them. Then, okay. When we are talking about tuning, yes, we can always tuning some applications like Samba file and print sharing. We can enable IIO. This is extreme options. We can use row read and write. We can turn on opportunistic locking. We can switch off or use a smaller log level. And if we are using old version of Samba, maybe version 2, just switch it to version 4. It's not hard and it's much faster. Okay, when we are talking about database optimization, and if you are using MySQL, then you can use MySQL tuning applications. I have a lot of web hosting services. One of really fine tool is MySQL Tuner. It will watch your web MySQL server for 24 or 48 hours, and he will say to you what options you need to change in my.cfn configuration. You can then optimize tables, maybe look which tables are using, maybe change database. Okay, when we are talking about OpenLDAP tuning, the most important tuning aspect for OpenLDAP is deciding what attributes you want to build indexes on. This is one example. If you add the following parameters to slapped.conf before entering the info into the database, they will all get indexed and performance will increase. Then when we are talking about Apache, make sure you are starting a ton of initial daemons. If you want good benchmark scores, you can change this in httpd conf or default conf. If your websites are slow on Apache server, use optimizers, use memcache, tune your Apache, minimize numbers of Apache modules, don't use unneeded modules, maybe try to change Apache for Nginx, which is in some occasions faster. Then when we are talking about benchmark, a good set of benchmarking utilities are often very helpful in doing system tuning work. It is impossible to duplicate real-world situations, but that isn't really the goal of a good benchmarking. A good benchmark typically tries to measure the performance of one particular thing very accurately. If you understand what the benchmarks are doing, they can be very useful tools. Benchmarking tools, Bonnie++. It's a free file system benchmarking tool for Unix-like operating systems. dbbench is a tool for generate IO workloads, HTTP load, run multiple HTTP fetches in parallel, DKFTP bench like dbbench, TIObench is a multi-threaded IO benchmark, TTCP utility program for measuring network throughput, netperf, networking performance tester, and iperf, network performance tester. This is my favorite, iperf. It will run iperf server and iperf client to test network speed. Okay, identify and solve performance issues. You must understand the problem. Half of the problem is solved when you clearly understand what the problem is. Monitor and collect data. After defining the problem clearly, monitor the system and try to collect as much data as possible on various subsystems. Eliminate and narrow down issues. After having a list of potential issues, dive into each one of them and eliminate any non-issues. And the most important, make one change at a time. Don't try to make multiple changes at one time. We have started to optimize servers in our company, I think now 2-3 years ago. We have lots of virtualized servers on KVM, and I think now all things are running very smoothly, but we really need a lot of time to make servers to be optimized as much as we can. That was all for today. If anyone has questions, you can ask now. We have, I think, 15 minutes. You can write me an email. So, any questions?
And most of your advices, I fully agree. Compiling the kernel, I do not understand fully what you want to save there, because of course the new kernel will be smaller, but on a server, the space the kernel needs is neglectable in my experience. So what, of course, then you have a bit better locality, but I really don't think that's measurable efforts. Do you have measurable enhancement? Do you have examples that you really get measurable improvements on a big server by the kernel? On embedded, it's a complete different story, but on servers.
He's talking more about real-time kernels on operating systems or on applications which are using, which must use real-time kernel, but these compiling kernel are still from 10 years ago, 15 years ago. I have started with Linux in 1993, 1994, then the first thing when you installed Linux on server was, I must compile this kernel. Now you don't need to recompile your kernel, but I always said that all kernels have too many modules included, that all kernels is made for many servers. It's not, and if you compile your new kernel, you can compile it that it will run smoothly and the best on your servers. You will not gain any really high performance issues, but maybe on some old systems or for your own fate. Anyone else? Okay, then thanks for your patience. I will be here today, tomorrow, and on Monday, and you can ask everything. Thank you.